Menurut saya tahu. Pentingnya tentu mewakili. Oh, dua. Iya. Iki ngene, wes kurang bener ora jabi Pak. Maksudnya kurang bener kita. Baik bener. Nah, lagi volume yang putih, Pak. Ini volume ini. Oh, gini gitu. Cek satu dua dicoba. Checking satu dua dicoba. Cek. Cek satu dua. Checking satu dua dicoba. Cek cek satu dua dicoba. Checking. Cek satu dua dicoba. Assalamualaikum warahmatullahi wabarakatuh. Satu dua dicoba. Checking. Kurang banter Mas. Satu dua satu. Warahmatullahi wabarakatuh. Kurang. Wes. Satu dua dicoba. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, alhamdulillahirabbil alamin. Pun tiga. Pun iki mampare Pak Afif nggih sekali. Yes. Anu pembicaraannya. Mbak, sebelah sini, Mbak. Situ cowok. Ini Pak. nanti pembicaraan nih. Oh, yang ngagem deh. Oh, oke. Live YouTube gitu. Jadi mic dan itu ya? Enggak, ini ditaruh taruh. Mic tetap pakai. Mic tetap. Ini cuma inputnya ke YouTube. Yang dari perempuan dari kanan ya, kan sudah kiri, sedangkan menempati kursi yang depan dahulu, ini ada banyak kursi yang berbeda jadi kanan. Emang, nyalanya bagus. Makanya sana ke YouTube Pak. Tek YouTube. Kan, kan. Oh YouTube ya. Tapi ini sudah. Iya. Tinggal pakai sini. Tetap pakai mic. Oke. And just we live in YouTube. So we can have and Zoom. So so, yeah. So yes. Okay. That's right. Yes. There's also use. Yes. Use both. Yes. And this one too. Yes. Okay. One for. Okay. Okay. All right. And to start, students are still coming, so we'll wait for some time. We just when and Nawaz and Nawaz from University of Singapore and Dr. Tatar from Australia and our student before we day and we will start so uh, like, uh, uh, yes, uh, today like um, with the session, to session, introduction and mentoring. So session with oh in on the and answer participants. So the student you can prepare your question. Jadi can prepare your question like start note dan siapkan di tengah-tengah sesi, di atau di akhir sesi nanti akan ditawari pertanyaan. pertanyaan dari uh, jika menyiapkan pertanyaan. Oke, siapkan pertanyaannya. You can prepare your question somehow. So and I said the for Dr. Nawaz. The first time.
Thank you so much. Assalamu alaikum. What was the first presentation from Dr. Farha yesterday? What sort of data model was that? And Dr. Farha yesterday discussed with you a data model. What's the name of that data model? You were there yesterday or not? You were not the student yesterday. So Dr. Farha covered vector data model. She talked about point, line, polygon. How to digitize the real world and how to develop a database, spatial database. So vector data modeling, all sort of data modeling purpose is to develop database. That was first part. The second part yesterday was about raster data model. That was bringing the reality, acquire the reality, and develop a spatial database, bring it, put. Today, we talk about how to make use of that database. Either it's a vector data, how to visualize. Visualize means how to be in that vision. So we talk about spatial data visualization today, and we share this presentation together. So it's a spatial data visualization. Abbreviation of this is SDV. So if Dr. Farha asks you what is SDV, it's a spatial data visualization. So yesterday, ask the question and take the answer from the system of your question. As usual, Dr. Farha will be very, very slow. I will try to become emotional. I can't be slow. So try to understand, follow with me. I will try my best that I should. And emotional means speed up. But I will try not to do this because I'm in solo. I'm not in NUS. I'm not in Australia. I'm not in Holland. So I was teaching all these places, Holland, Egypt, Darwin, Australia, and Singapore. The Farha will cover. Dr. Farha will cover what is map type, symbolization, classified features, maybe most of the things you already know. But she will this element with reference to spatial data. This thing, what we are talking with data visualization, traditionally this was known as cartography or cartography. Cartography, you know cartography, the term. By the way, it's absolutely it's an old term. It's old, it's gone. But in cartography, so new cartography is called, is the new of cartography, right? So Dr. Farha will talk to you from cartographic knowledge to all spatial data After Dr. Farah finished, stop somewhere in between. I will talk about lot of new things. So here you see the term AR, and I use lot of abbreviation AR. I will let you. I will teach you, and you should know what is around now. It's a new cartography. It's a new spatial data visualization. And I'll talk about VR. VR is virtual reality. Maybe you are all familiar, you are using it, but you don't know what is virtual reality. Let me decipher this, decode this, what is virtual ML, machine language. Because it's a modern era, not old maps, not cartography. We need to know the new things, machine learning, intelligence. So machine learning and artificial intelligence integrated into spatial data visualization, no more cartography, any new things, and new things are emerging, and you should embrace yourself with the new things. Generation, okay? You know a lot. Mobile phone. I know you are much, much better than us doing things with the mobile phone. Why don't you do the machine learning and artificial intelligence? So I will also talk about integrated dashboard, mobile SD. The principal design was a new spatial data visualization. With this, I will hand over you to Dr. Farah Sattar.
Assalamualaikum everyone. I'm Farhi. Good morning. So,
My Islamat Pagi too, sorry.
but he forgot, I reminded him to say Assalamualaikum. So, we are also learning Indonesian here. We are very, at a low level, but he has started to learn a number. So,
It's okay, it's okay, it's okay, it's okay.
That's our level of India. So regarding language or that I am very far, or at some places I am not clear about the concept or what I am talking about, please raise your hand, stop me, or Dr. Farah, please repeat it. Can you say it again? Say it, and I will do that. So what I am saying, you are understanding it? I am clear that what I am talking. Good. So how many of you attended yesterday's session? There was a lecture yesterday which Dr. Nawaz explained. So we talked about data models. Data models,
new student.
IS, Geography Information System. We talked about two types of data models. One was vector data model and other is raster data model. So he has just delivered some introduction of yesterday's lecture. So I'm just repeating it a little bit. So maybe for those of you who haven't attended yesterday, can get some of the key points, some of the important points of yesterday's lecture. So with vector data model, we use three types of features. One is point, other is line, and third are polygons. So its base is using point, line, and polygons, and then store spatial features in our geodatabase. So spatial features means anything which has some position on Earth's surface. It has some geographic location. So you can make use of term geographic, geospatial, or spatial. They all have same meaning, but the different terminology, but it means that it has some coordinates on Earth's surface. For example, the building in which we are sitting here, you have that on map, and if you look at that on map, you can see position. When I say position, you are geographer, so for position means it's coordinates. Coordinates in terms of latitude or longitude. And then you can also convert that in some other coordinate systems. They might be just a simple on graphs like Cartesian coordinates, or maybe using other coordinate systems where you are geographic students and you know that how to produce map using different type of coordinate systems as well as using different type of projection, because when you have data at the different place of the earth, for example, which are close to the equator, how to present that, how to use different type of projection systems to represent your data. And for raster data model, the other data model which we talked about yesterday, that was raster data model. Raster data model that is based upon pixel information or cell. We also say pixel or cell. And so that spatial data, that is into the form of aerial photographs or maybe satellite images, or maybe from some other sources using your normal camera, just a picture. Yes, that is also spatial data. That if you have assigned, you have georeferenced that, you have assigned the coordinates to that photographs, that also become the spatial data. So they were the two data models basically that we use in geographic information systems and in GIS. So today's lecture is when we have stored all that data, either that is by using vector data model that is based upon point, line, and polygon, or the other raster data model, which is based upon pixels or the cells information into the form of the different type of satellite images. So how we have to represent that in a database, how do we visualize that? If certain type of information is associated with that map or image, how you are going to present that it provides you the information which is meaningful, which you are looking for, which you can use for the analysis, or maybe the results of your analysis, that what you have presented, you are showing that on the map. I'm know that sure that most of you are familiar with map. Can you tell me or you name different type of maps? Okay, just let me know how many of you have mobile phones with you. Raise your hands. How many of you have Google Map on your head? Raise your hand. I can't see. Yes. Okay. How many of you have Google Map? Oh, that's good to see that. So many hands here. Okay. I can also see your hand. Okay. So with Google Map, what kind of information you can see? What you can see on Google Map? Little bit louder. I'm deaf. I can't hear. Okay, I come closer to you so you can say that in mic. So what kind of information do you see on a Google Map? No, not anything. Not any. You can't see me. You can't see me on Google Map. Not anything. Just be specific. Huh? Map. So what do you see on map? Location. Other thing. Use the mic. What? Railways. Very good. What do you mean? So you see on map roads, railways, location information. What else? So do you see buildings? Do you use GPS? So when you use GPS, what do you see there? How do you find your way? Isn't that map? It is guiding you, okay, this is your starting point, maybe that is your location, how you have to move from one point to another. So it will be telling you, okay, just go from 500 meters, take right turn, go to left. So it will be guiding you. But underneath, what does work? That's a map. And that map is because when you will be just zooming it, it will provide you more information. So it actually tells you a scale. Have you seen the world map? So on world map, you see maybe the boundaries of different countries. And within countries, you see the different city locations. For example, on Indonesia map, you see Jakarta, which is just into the form of a dot. But when you see the map of Jakarta, that's at a different scale, it will provide you more information. What districts are there? What other cities are there? What are the different towns? What are the highways or the main roads are there? What are the secondary roads of Jakarta are there? Can you think about the different type of scales? So there are small scale maps, there are large scale maps. So small scale maps, which scale maps are world maps, which are something like 1 to 1,000 at scale, 1 to 250,000 scale. So you see lot of area, big area is covered, but with less information. And with large scale map, little area, small area will be covered, but it will provide you more information. For example, with your GPS, the map which you see, it is most of the time, this is the large scale map because as you are moving, you are also looking and visualizing small roads there. Even small streets are visible on that map, but you can't see those small streets on a world map. So on a small scale map, small information will be there. On a large scale map, large information will be there. Easy to remember? So don't forget that what kind of information is associated with different type of maps, with different type of scale of map. So that was just about the some of the, that the geography or the map related information. Now we are moving to the next step, how we have to store that information and how we have to visualize that. Because with the map, maybe you can see, okay, with the Indonesia map, what are the important tourist sites? What are the important places to go? Like I am here. I think this is my third time here in Indonesia, time at Solo. Still, I am interested to know that what are the different tourist sites, but which are the really good points to go and to see. They might be historical points. They might be. I also like shopping. I would like to know. So all that information I need to know, and maybe a map is really a helpful thing for me. But can you think about I am talking about? And it is related to, let's say, with the Surukarta. And with the Surukarta, so all that information, how we have to store that into the form of a digital map and how we have to show that on a screen or for us to understand. So this is, all that I am going to talk about different type of map, different type of information which is associated with map, how we have to show different type of data, how we have to show, maybe if I want to see where are the different, the shopping center, how to display that on the map. I know that, okay, which is closer one from here, from the university, that where I can go in less time. I have my own priorities. I have my own, the information. Maybe I would like not to go too far. I would like to prefer to go somewhere which are really close by, where there is not much traffic, so the road is easy to go, no traffic jams. I go there, I just do my work, I come back quickly. So it means everyone have, that the different priorities. Everyone have the different way of working, and you need to get information from database as you would like. And everyone's query. So this is the query that when we put question to database, so that is in technical terms, we are saying, okay, we are putting our query with the database, find the answers of our question. And how you can do that? Once you have your digital database with you, once just, information, let's we start with some of the history of the map. So Sawyer was the first person who actually provided the first time the definition of a map. So a map speaks across the barriers of language. It is sometimes claimed as the language of geography as well. So what so that also provides the information about, okay, maybe here. And if I'm just looking at the map, what are the hotels at the Surakarta? And I am looking at the different hotels positions there. So that may be showing into the different points. So it means maps are really an easy way to show the information in a way that is easy to access. And also, with the help of images, with the help of symbols, when you go out and when you are follow traffic rules, so what you are following, you are not reading all that the information, what are the different, you are following symbols, isn't it? Traffic lights, what are that? Symbols. You know that when they stop, when there is green light, you have to go. And when you road, you can see what kind of road it is. Speed limit is there. On the highways, you can see different, the type of speed limit. And also when if there are, the road is not good, you can see the sign that, okay, the road is under construction or road is not good. Or maybe if you are traveling in remote areas and there are some danger zones, for example, a wildlife is there. So there are signs, there are symbols, and symbols convey you the information really in a meaningful way, quickly and easy. Just looking at the symbol when you are traveling, and then you see, okay, speed limit sign is 60. So you know, okay, I don't have to overspeed, I don't have to go over or more than, that the speed of the 60 kilometers. So the same thing we use in maps as well to provide the information. Now, more related to map, the different, what kind of information we can get. So, and here I have some more definitions about the map. Is a visual representation of an area or a part of an area, typically on a flat surface. So this is really, really fine paper map. And the paper map, they are on two dimension or the 2D. But in reality is 3D, three dimension, because it has length, width, and height, and that we see all the time. So the projection systems, what I have talked before, they are used just to minimize those errors which can arise due to the third dimension, due to the height and due to the earth curvature, we have to accommodate that. And that's the way that which the geographers are, I will say, from centuries. That how that the earth curvature information and to provide the accurate maps. Then because we are representing the earth surface as a part on a flat surface, and that is according to a scale. So scale, I have, do you know what is the word map? Do you know the map which is you use in your GPS, and you can just compare those maps, you can see that there are the different scales. So scale which I have talked about. Can you tell me? I told you two types of scales which I talked. The one map which has small information with that, what do we say? Which cover more area but less information. What are those maps called? Loud? Yes? So I'm getting answer. Okay. The maps which cover more area but provide you less information. Yes? So which maps they are? Can you tell me? You were saying it right. Small scale map. Can we clap for that answer? And opposite of that, they are called large scale maps. So with the large scale map, they cover less area but provide you more information, right? So now we are going to look at into the GIS, how we have to store that, how we have to visualize that information. Here you can see that maps versus GIS. So the important thing is how you have to display data, how you have to show your data on a map. So that's we are going to see why we need to show our data, because we want to analyze that. Analyze, because in real world we see a lot of the problems we work with, different type of research problem, and of those problems. For example, let's we discuss that there is a flood event here at Surakata, and you need to know that how you are going to mitigate that problem, mitigate that flood hazard. And you want to make it sure when next time, if that situation happen, when next time that phenomenon happen again, you want to do preparation for that. You want to have some, that the some measures for that, just to avoid or to prevent that. Or if it happened, then you have some solution for that. So this is, a kind of analysis, a kind of problem for which. So with the flood phenomena, what you think will be, the flood will depend upon the precipitation or on the rainfall. So how much rain is getting here? If there is more, if there are dense rainfall, so there are likely, that the chances of the flood that will be higher. Then you also need to have the information about the surrounding areas where there are urban, where there are a lot of population which are residing there. So the other information you need about the population information, or the urban areas are nearby, or maybe if it is not, then maybe let's say there are the parts that where not a lot of population is nearby. Maybe there are agricultural land. How you have to prevent that? How you have to prevent, how you have to save your, that information is also free. Then slope information, from where water is coming down, where it is going to be affected. So if you just, take it into more. It means that it requires you with the analysis data more information that a digital map gives you, then every information, whether that is related to the precipitation or the rainfall information, that area's slope information, population density information, nearby maybe the different the facilities which can help with maybe which can help the affected area. So that information. So you can there are number of the different type of data that we and that we need. If you have all that in map layers, you combine them together, you visualize that, you relate one layer with another one, and then you make connection. You perform your analysis, and then you come up with the best solution, with the solution that provides the information or maybe the best decision making about how you have to control the floods, and if floods happen, how you have to perform those that the facilities, how you have to save those persons which are affected by that flood in that area. So a very simple example, just one phenomenon I have discussed. But as a geographer, you know that there are lot of other things. Just think about our recent epidemics, Corona, COVID-19. So how terrible that was, where it has really affected the whole world. Everyone was affected by that. And this is that how you can also study how the spread of a particular disease is happening in an area, and how you have to control that, because that we were looking, we were also having from the news in which areas it is spreading, in which part of the world it is spreading with a more with a rapid pace. So they all are the different problems that what we see, what we actually we see as a human being, and they all are related to some of the aspects related to the human geography as well. The problems even related to the health, and even after that, if we look at that, the effect of the COVID in a socio-economic perspective, we also see inflation. So it has also affected people's buying capacity. It has also affected, that the everyday commodities prices, they are high. And if you want to study that kind of socio-economic phenomenon, then you also need to have that information. But again, it will be related with the different type of information, related with different type of maps. Maybe you want to study that the socio-economic perspectives or condition or the effects of COVID-19 at solo. You need to have all that information related to that phenomenon, but it should be will be easy for you just to visualize that and just to have that information. Next, and this is just talking about different type of map, different type of information that is associated with this one. So this is a map of Indonesia, and you can also see Indian Ocean here, see here, but also see that just pay attention upon the use colors as well. And as a cartographer, you know that in the map we use not only symbols, but we also use different type of colors. Every time when you will see water bodies, whether they are sea, rivers, lakes, they will be represented in which color? Blue color. And when you see flat surface, there is a vegetation. So we see that in green color. And from the topographic point of view, when there are height, elevation with the natural features, or let's say with the uh, with mountain. So you will see with the mountain, so the bottom of that will be represented as green color, and as there is the increase in elevation, it will be represented in brown color, and as the elevation will increase, so the top of the mountain, that will be represented as light color, top of the mountain. So these are the standard colors that we use in, and here you can see that as well. So these are the high elevated areas, and this is that we can see our sea information, and also see some of the road information here. So this is just, I will say, not the small scale map, but small to medium, I should say. And so here I have other map. And now you can see it is showing you different kind of information here. So you can see the different type of, that the boundaries of the different districts here, different city information. You can also see some of the road information here. And but it is providing you the information of the same area, but at a different level, at a different scale. Let's we see another map. Now, you can also see here, okay, the location of the Surukarta, that has been given very precisely, and more information is associated with that. So you can see the main highway here, you can see in the water bodies, rivers here. Underneath that, these lines, you can also see the roads and street network as well. While that was not visible in previous map, if I just go back, look at this one. You can see road network here, right? So it means that you are having different type of information associated with type map. And this is the way that how do you store that information in the map associated with the different type of scale. Now I have here the map of Solo. So now you can see just that the different boundaries here, which is the different maybe different areas here at the Solo. Then you can also see that the outer region, and this is one that also normal. So here also I'm reading it wrong. But anyhow, this is really a map which is providing you more information about Solo. And here I have a previous one. I didn't have the name of those associated areas here, but in that map I can see, okay, there are information about the different type of districts or different type of areas here. You can see the name of those different, that the administrative units here. You can also see that where it is located here. This is the East Java. Here is the Yogyakarta, which is the associated or the related one. You can also see the direction here at the bottom, which is the north and south direction, and a title. So this is the way that how do we present the information on a map, and then other, the associated thing. Now coming towards that, if you want to see the information which is associated with a specific location, how you are going to store that, and how you are going to visualize that in a map. So here, this is on this map, you are looking at, that the situation of novel coronavirus pneumonia cases, and that the situation of China by that time. And at left, at right hand side, you are looking at the legend. You can see different colors. So this is the situation or the location by that time of the pneumonia cases, and you can see some of the information that is here under different type of colors, different type of classes. So 1 till 40, 41 till 80, 81 till 160. So these are the classes which are associated with different type of colors. So it means the same information like the pneumonia cases, but you are looking or you are visualizing that information in a precise way. The Hubert. So if you just look at that from that, pneumonia cases in China, but in a more organized and in a classified way. And when you will have that map in a GIS, if you will click on any type of area here, it will show you a table that how do we store that information using the different data models in a GIS, and it will show you the relevant table and it will provide you more information, whatever you have stored there. Of course, it will show you what you have stored. It will not just pick automatically, but the beauty of this technology and the information technology and the using the data into the digital form that provide us that possibility and ease of use, that if you have data which you have not collected but you want to use it from some other organization, that we say secondary data with some other person, like you have the health department and you have all that information that is lying with that department, but you use some of the data from health department for your applications. You are requesting the health department, okay, I need that information for Solo City. Can you get that data? And yes, with their permission, you can make use of the data. And this will be called the secondary data source, which you have not collected by yourself. But there are other ways that where we call your research persons, you are collecting data by yourself from the people. Maybe you are performing surveys, you are performing interviews, you are storing all the information in a table or in tabular form. You are making those tables, you are developing your database, and when you are performing such, so you have all that information. So that is a holistic view. Holistic means a complete view. Whatever information is needed, you have that at front of you. And why do you need more information? You need more information and the related or the associated data with that to do the right decision making, to find the problem, what you are investigating. And this is remember one thing, when you associated with some specific location or so normally you don't change that the entire area or the inside administrative unit, but what will be changed, just the data or the information that is associated with some specific location, that will be changed. So this is also an important point to remember. For example, if you are having map of Solo, you want to study that the spread of disease, anything, and then so the your map area will be same, but the information which you have stored into the form of the different tables that will change. And every time you will click on at the different type of information, you can see that help you to visualize that. How to visualize that? There are GIS based softwares which helps you to look at that map information. Maybe you are also using ArcGIS. Are you using that? So you can also visualize the data. And which I am talking about because the softwares, they are really, really very user friendly. Whatever the data you have, it is just a matter of 1 or 2 clicks, and it will provide you the information how you would like to see that, whether it is into the form of the classified data or maybe just nominal data that where you are creative boundaries or so on. Now, here I have an map just to discuss with you. And this is the large metro areas across the country. And you can see, the outbreak, number of confirmed COVID-19 cases. And so this was the map, I think that was 2020. And then you can see this. So this is the different different types of circles have been used that shows the of spread of coronavirus cases. The more cases, there will be the bigger circles, less cases, smaller circles, and into the areas that where they are reported. So of that map, and then you can see, okay, with the small circle, it is representing 1,000 cases, maybe more than that. There are 17,500, 35,500. So as the circle is increasing, you can also see the relative that is. So what technique of visualization map you have seen? I have used colors for that just to represent the spread of the coronavirus cases and the intensity of those cases there. But here you are looking at presenting the different type of size of the circles. They are representing the associated data with that. And so this is another visualization technique. So, and this is really providing the information in a clear and in a precise way. So rather than having 30 or 40 pages of reports, what you are going to read, map is providing you in precise and easy way. So you are really getting that. And if this is a digital map, which you are looking at, okay, so these are the area where more cases have been reported. We have to adopt some measures here. These are the areas where not many cases have been reported. So maybe we need less facilities in here. You can do that. Okay, now I'm just revising. The first visualization method, what you have used, make use of colors, classify your data, use different type of colors, maybe with the same color, but with the different levels, the different shades. Darker shades, they will be representing the intense data, more data there. And same is the case, the symbols. Small circles here, they are representing small cases, less number of data, and bigger circles, they are representing more cases here, right? So what we have learned now, use of colors and use of symbols for data visualization. And what data was there? Data related to coronavirus cases. So these are the different examples for you to remember it and to understand that. Now, I have map here. So this is the map of heat map of accident hotspots in Singapore based on around 15 days of accident data in June 2018. So this is also important that when you have collected data, so maybe in some cases you need historical data, you need to study a phenomena in a more detailed way. But in other cases, you just need some recent information. If I want to see, let's say the heat map or the hotspot for those incidents, I will prefer to have current data, maybe from the last year's data, maybe from the 2018 year data. So that will be the data from 2018. So that will be helpful for me just to get some trend, but to get the recent information, just the last year data, that will be helpful for me. So it will depend upon that what you want to study. Are you going to investigate the trend of a particular phenomena, or you are just what is happening at a particular time, maybe currently what is happening. So here you can see that the legend, that how it has been providing from 10 till 70, and also with the color. And remember, like how I pick map, the use of colors, that is in a standard way. So the same is the case here with the heat map. So whenever you will looking at the heat map, so the standard way to represent that data with the red color. So more intense, the heat areas. So you have to make use of the bright red color, and the lighter color, they will represent the lesser temperature. This is also, the colors also have their own language. The colors have their own logics to use that. Also remember that for the data visualization technique. Now, if I just synthesize the different type of examples and what I have discussed with you, just to provide different, so we can see here, we can have different type of map. So some are journal reference or thematic map, and the other are the information which they have the qualitative or quantitative in nature. So qualitative, we provide you some characteristics of a special phenomenon there. So they will be the qualitative data. Other will be quantitative. You need specific number, like in the previous example, in the case of the pneumonia cases in China. So I want to see how many cases have been reported in China at the northern part of China. So maybe there were 3,000 or more. So I need to get some specific figures. So that is called, so where numbers are associated with that, with your data or information, so that will be called your quantitative data. And when you are just having, some the characteristics of a particular phenomenon, so that will be called your qualitative data. So qualitative data and quantitative data, you also have to make sure how you are going to represent that. What kind of, that the visualization technique you are use of colors, making use of symbols, selection of colors, standard um, uh, colors which represent a particular phenomena. So this is really important. Why? Because once you have selected the standard colors or things, so that will provide you the more precise information. Okay, with the general reference map, so you can also see that we can also make use for the navigation purposes, as well as at the we use standardized symbolization and scale. So scale, I hope that is clear to us now. We use small scale map, we use large scale map, make use of different type of symbols. I have also discuss with you about the symbols that what we use on the road, and it also provides you the information. So the same thing is with the symbol that what we use for the, for certain other things, uh, as well as the use of the color and how you have to display a large variety of spatial features. So sometimes, with the symbol, for example, um, you have want to perform the forest thing, and you need to identify the different type of trees there. So how many palm trees are there? How many eucalyptus want? Maybe they are just all trees, but you them by using different symbols. So with the with the palm tree with the palm trees, maybe you will make use of some symbol which is really close to the shape of the palm tree with the long leaves and it's different strings with that. Maybe with the eucalyptus trees, you will make different type of symbols. For example, that has the small leaves with that. So this is just to provide you an example. So with the same type of map, but if you want to specify, you want to identify the different type of trees there, so you can also make use of different type of symbols as well. So selection of symbols, that will also be helpful for you, because when in using your map, you are only interested just to see, okay, how many palm trees are there, and you are just displaying palm trees and nothing else in a particular forest. So in this way, if you have managed your database in a way that is really in a more organized way, and so it will help you provide you to perform precise analysis. Now we also that the apps, and they are for the special purposes, because they display, they show you the special for one or for more selected themes. So themes are, they based. Here I have, map of the Singapore population density, and it is showing me here. We can see the legend, which is showing, okay, this is the color is showing the lowest, and this is showing the population density that which is the highest. And in between that, different colors are representing different type of classes, and those classes are lowest, very low, low, high, very high, and highest. So you can see, just with the help of that legend, you can also look at, okay, in which area of the Singapore population density is really high, or where the population density is really low. So you can also classify the information as well. And here I have another map where you can see two different type of information. You can relate that, you can make selection with the different type of layers, and then you can find meaningful information out of that. So what is this? So this is the map of the population density and drought to rice fields in Surakarta residence. So you can see the population density legend here. So the darker color, that is representing here, that the more cases there, and this is the lighter cases, sorry, the light yellow, which is representing less than 100, 1000 population density there. And just based upon that classification, you can look at that, the one information that this map is depicting very clearly about the population density here at the Surakarta. But at the same time, you also want to study what are the situation of the rice fields there. So you can see, okay, so these shaded lines, which is showing you the information prone to drought area. So where the drought can happen. So you can see, okay, what are the urban population nearby, how it can be affected if the people are involved in agricultural, may affect their income. It may also affect the food supply availability. So you can see, so this is a very good example. Different type of phenomenon together. Now you are studying in this map the population information and the potential areas where drought can occur. So see, you can also look at drought area. There are the different settlements are here, so you can also study into that. And then based upon that information, based upon you can formulate your research question. You can find out what do you need to know about from that kind of situation. So this is also giving you a good idea about that, how if you have different type of information, how you can relate that with different type of data layers. And remember that in GIS, we store information into different type of layers, and you can just display those layers one on the other, not only for the visualization purposes, but also for your analysis purposes as well. Now, this is another example of the qualitative map, and this is the land use map, and this is the high resolution map of Singapore, Singapore's terrestrial ecosystem. So you can see different type of land use classes are here, and so these so that the vegetation based on the broad human management. So this is a good example of the qualitative map. The qualitative information lies, you can visualize by using different type of colors there. But here you need to normally with the vegetation, wherever there is vegetation, as a standard selection of the use of the color, we use green color. Like we use blue color, then ones. So you also have to be careful, and as a geographer, you should be really careful about the selection of the relevant colors, selection of the relevant symbols, what you are going to display or for your data visualization. Now, so for the quantitative maps, we can make use of colors, we can make use of size of symbol, we can also make use of charts. Chart, you know that you can also have graphs. Maybe you can make use of pie graphs. You know that. What are the pie graphs? And you also have sometime that the histograms which is also showing the data, but just with the histogram we can study that where we have the high values and which areas we have lesser data is there. So these are another way to show your data in a more your statistical data in a more precise way. And then we make use of, that the quantitative maps. We can make use of dot maps, droplet map, choropleth map, graduated symbol map, pie charts, flow map. So flow map that where when we need to see that where the flow of a particular phenomenon is going on. For example, in the case of with the water bodies, from where water is coming, where it is merging with the other stream, the catchment downstream, and where it is heading towards. And normally with the flow chart with that kind of cases, and a arrow is also attached with that, just to show the direction of the flow. But also with the flow, we have the other phenomenon. I have another map which I'm talking. And then we have the map that we use ISO lines that shows different type of data and then we can also see in which area we have the less data. So they all are different techniques, different ways of showing your quantitative maps the way, and you can use all those techniques there. So this is an example of the dot map, and this is showing the US population distribution in 2010. And again, you can see the dots, which is representing the different type of data classes here. So this is an example of using your your quantitative data by using dots. Then this is again, with the help of the dots, you can see the current population estimates, and then one dot is representing 50 people, and here you can see the different ethnic groups in USA and their representation. This is another example for you. Okay, with the corrupted map, you can also make use of the different symbols based upon the administrative units here. So this is the United States population change from 1990 to 2000, and then you can also change that. You see that how that change has happened by using the different, and you have made use of the different classified colors here, the color scheme, which is showing the different type of classes about the change in the population, and this is the time period. And you can also see that the time information, the temporal information that is also there, because you are providing that information in the specific unit of time slot. Then we have graduated symbol map. So graduated symbol map, I have also shown you some of the other example with the help of the different colors and associated data. You different size symbols can be used, different range of values. You can see different range of values with the classification here. You can make use, and other example, you have oil consumption here, and then you can also see, the same technique, the same thing. Bigger symbol, whatever you have selected, more data it will show. Small size of symbol that will show less number of values. Then we have chart maps, which I was talking about. You can also make display your statistical data into the form of pie charts or maybe histograms. Sometime, sometime maybe the different other techniques you can make use of that line chart. Sometimes you can also make use, but that is for whole of the data. So the circle size can be made proportional to the value of the state population as well as the subdivision. So these are the ways that how you can show by using the pie chart. But you can also see this is also really a precise way just to get the information how those pie graphs are showing that, and these are the ratio from the population, Hispanic population as percent of the total population. So this is a very the simple information you can also show using the pie graphs. Chart maps, which I was just discussing with you. You can make use of either pie charts or the bar charts. So bars are also really easy and a very convenient way to show your data, because where the bars are high, you can see the more data is there. Where there are the less, the bar size is smaller, it is representing the less data. So even if you don't get the exact number of that data, but just by look at your map, when you have used the right technique for your spatial data visualization, it is conveying you information right in a first glance just by looking at your data in a more precise and more meaningful way that you can get okay. So this is the situation, the current situation in the particular, and you can also determine your plan, your strategy for your research, the next phases or the next steps. Then flow map, which I have talked about. So maybe the example of the flow map, there might be stream flow, traffic, or the migration data. So these are the examples. Maybe how many people have been migrated from, let's say, from 2015 till 2020 to UK. You want to see that the migration rate. And this is also related to, very much related to, that when you perform the demographic surveys or you want to perform the demographic studies in geography. So this technique you can also make use there, that maybe the flow map, maybe from which areas or which part of the world people have migrated. There may be many, that are relevant aspects which you can say. This is also an example of a flow map, that where you can make use of the different range of the values over there. And then is a reflect map that this is also a technique that where you can make use of iso lines to represent a surface. So each iso line connects points of equal value. You have seen the topographic map, and on topographic map you have seen the contours. Have you seen that? If you have seen, raise your hand. Contour map. Just raise your hand. Hi. Okay, so many of you have seen the contour map. What does contours represent? Height. Very good. Very good. Perfect. Contours represent height of Earth's surface, and out of that height information, we produce them digital elevation model that we store in our system. And so this is also a kind of isolines, but when we say contours mean that they represent a specific height in a particular area, and those are, that the lines that where that particular height is existing. And how do we see that? How do we store that information? On a paper map, you see contour lines that where height information. You can also see that with each contour line, what kind of height it is representing. But you can also make use of that information when you have stored that information in your GIS system, because it will provide you to look at and visualize the height information or the elevation information using the technique that where you can see that information in 3D, and that we see into the form of a DEM, digital elevation model, or DTM, that is stands for digital terrain model, and DSM, digital surface model. So with them, it will only show you the heights, digital terrain model. It will also include the mapping as well, but digital surface model, it will also provide you the height information, but as well as all the what is existing on the Earth surface, that will also be that. So digital surface model that will provide you more information in terms of height and in terms of natural and man-made features as well. So just to remember that these three terms, when you are looking them on your GIS system, what do we mean by them? What do we mean by DTM? What do we mean by digital surface model? Now, so they were related to the elevation and the height point, which we normally use with reference to the mean surface level, but mean sea level. But with the iso lines, that can be any phenomenon that which you want to represent other than height. So for that, the term what we use, the use of the isolines, and they might, the different type of things maybe here. This is the isoplot where the classification or the rainfall information has been given by using the isolines here. You can see the associated color here. So this is another way to show, that phenomenon by using the isolines here. Symbolization. This is the example that which I have just also discuss with you about using the different colors, markers, size, width, angles, patterns, transparency, and other properties with the symbols which are associated with that. And then you can see also, there are classes with the symbols as well, with the trees which are older, based upon their characteristics, based upon their age, based upon their health. You can also store all that information in your database, and also you can associate, or you can just just link that with its symbol as well. So this is the pictographic symbol, and it doesn't mean that all of the time you have to store the symbol what your software is providing. Maybe you want to create your own symbol. So what you will do? You will go to the field, make your photograph, and use that as a symbol to make it or to provide a more information in a more realistic way. So you know that, okay, these are the kind of trees which I have collected the image of that tree from the field. Now this is my map symbol. And this is, with the help of the technology, you can also create your own symbol based upon your preference. And okay, so with the symbolization, again, that three points, three types of symbols: point, line, and polygon. Points, remember, in the GIS-based data model using the vector data model, points represent position. Lines we commonly use to make the representation of the linear feature. So it means with the lines, it will provide you the position information and the length. So this is a special property. With the polygon, it will provide you the position information, but as well as length and width. And when 3D, three-dimensional that, so it will provide you the height information. And then you can also go for the different options for the symbolization, like shape, hue, orientation, value, size, and texture. So, what is shape? We have a good understanding of the different type of shapes. They can be just a standard one, like the rectangle or the circle or the triangle. So these are the different shapes. But again, you can also make use of different, the colors. So what are the different colors? So you can see on the color palette different type of color, but also with those colors you see different type of different shades. Maybe light shades to the medium level, and then to the darker shade. So those are called, the different hues with that colors. So you can also select a different type of hues to represent different type of classes. You can also include the direction with that orientation, like which I have just discussed with you. If you want to show the stream flow, so you are also adding arrows with those lines. So selection of colors, selection of symbols, really make an intelligent and wise decision about your selection. And okay, then we also have, that the different type of symbols, different type of values into the form of the coordinate map, where you are showing the intensity of a phenomena. So lighter colors, they represent the less numbers, and the darker colors, they represent the more data is associated with that. Sometimes you can also make use of textures with there. So it will depend upon that what you want to show. Maybe with a different type of land use practices, you can also make use of the selection of it. But these all things you can also see in your softwares as well. And it provides you a range of possibility of using the relevant symbols or the colors for the data visualization. So this is also, an example of the colors. So this is what I was talking about, the colors. So this is the three dimension of color: hue, lightness, value, and their saturation. So this is the hue, different type of colors here. So this is magenta, red, orange, yellow. This is just, the combination of yellow and green. So they called the different type of hues. And here you can see the values which are from 0 till 1, and they are representing from dark color to the lighter one, and this is related to the saturation. So saturation is the intensity of the color, and value is the lightness or the darkness of the colors. You need all these information of hue, saturation, and value. So hue is a particular wavelength of the color. Saturation is the amount of pigment. Pigment will tell you that how dark the color is. And I'm sure that the girls, you understand it very well about the pigment, because when you select your makeup products, you, particularly your eye shade, you go for, okay, which pigment is really high. So really, this is, I will say, easy for you to understand the concept of the pigment and the colors. And with the saturation is the intensity of color, and this is also, the different values are associated with that. So when you select colors to symbolize your data, you have to really take care of these three things: hue, value, and saturation. Three things for the selection of the colors: hue, value, and saturation. And because that will help you that you are not assigning the same color for the different classes. Otherwise, you will be a problem when you will be visualizing your data. Then classifying your features, and then you will have, the classified programming, number of classes, value ranges. So they all are, the classification method. So some methods of classification, they are based on per intervals, natural breaks. In some phenomena we see, okay, there are some natural breaks. So you have to classify your data accordingly, making use of quantile, mean standard deviation. Sometimes you make use of maximum breaks, and then you can make use of
Ada yang mau titip, Mas Danu udah ini. Kenapa titip nunggu barang? Buat
Text tester and the Fisher test.
main ya.
So this is an example of equal interval, and this method is like the interval between each class that is same, and that most of the time we do that. Classify data based upon the equal classes like 3 to 6, 6 to 10, and this is based upon, that how when we classify our data based upon the statistical group. So the lower limit of this class and the upper limit of this class, and these are most of the time they are same. So this is a statistical rule that when we classify our data. And so this is called equal interval classes with the natural rates. So classes are based upon the natural rules which are inherited in the data. So you can also see, okay, where the natural rates are. So maybe natural grouping similar values together, maximum the difference that where, so you class them in a separate class. So these are the natural rates there. And then you can also make use of quantile. So each class contains an equal number of value. And then you, for example, you have 10 counties grouped into 5 classes, and then each book contains 20 counties regardless of the value of the attributes. Another way using the quantile classification. And important, and which I'm sure in geography, you know that the important elements of your map elements are subtitles, legend, back area, frame line, and here you have the frame and the lead line here, which is showing value, your scale, your orientation is the direction, your north scale, your rectangles, your weight, inset. Inset is that how from which part, which part of the map you are showing into the whole page, and your data source from where you collected the data. So these are really important because when you compile your map, you need to remember that what are those map elements. And then, so here is another example of the Singapore residential population. So your map must have a title, your map must have a frame line, a lead line. In that case, from a bigger map, which part you are going to display is called insect. And here in this case, this piece is showing the world map, and this is, that the Singapore has been zoomed in, and this is the case balance here. And then you have that your data source from where you have collected that map. You have to your scale. On which scale, whether it's a small scale or a large scale, you have your vision, you have to have your orientation. So these all are the standard map, and so whenever you are compiling map, you have to remember that none of them are should be missed. Otherwise, that is not professional way of producing a map.
Sama sekalian.
And this is again, that one, and then we have straight lines. I have already shown to you. Scale, I have discussed that in detail. What do you mean by different type of scale? What kind of information is required? And so this is the example of different type of map scale, small scale to large scale. So with small scale, more area will be covered, less information is taken. With large scale, small area will be covered, more. Remember that not that this one and whenever you are
Tapi enak banget.
making it sure that you are that the right way, location is correct in terms of their coordinates, whatever you are using, you have a selection of the right projection system, the associated data which you want to show, that is really by using a standard color scheme or the system. And so the principle of map design, they are based on simplicity, balance, and contrast. And then we also have that you have to remove the complexity from your maps. Just make it simple. Just make it visible. What information you want. And balance layout with the map which I have shown you there. So there is a standard way, just showing the title here, showing the at that side, showing the map in that case. So it should be a balanced way. It should not be out of those sides because the next part is with Dr. Nawaz. And before he come here again. So this was my part, and just to share with you different type of maps, scales, information, data visualization technique, making use of colors, what are the way of selection of your colors, what does the different type of symbols represent. So the all techniques that go from the spatial data visualization. Now from this part onward, Dr. Nawaz will tell you about that what kind of the issues of the technology and so that's all from my part. And if you have any questions, I'm here and we can discuss that. Then you have
Okay, thank you, Dr. Farha. Please give applause for okay, Tarun, now we discuss a session or next.
Okay.
Oh, yes, okay. We have 5 minutes break time or rest time. So the presenter, thanks for your material and I know you have cappuccino. Dan beli. Oke teman-teman, kita istirahat dulu 5 menit dan sambil nanti ya mempersiapkan pertanyaan. Jadi nanti di akhir kita ada sesi di akhir. Sudah siap pertanyaannya? Kira-kira yang mau tanya siapa? Sudah ada? Kalau belum kita undi. Refresh yourself, bring some energy, okay? In the next hour with you. Dan teman-teman kalau mau keluar dulu mungkin jalan-jalan sedikit boleh karena udah duduk 2 jam ya 2 jam duduk boleh jalan-jalan tapi masuk lagi ya
Soalnya biar nggak kaku. Kalau mau ke toilet dulu silahkan.
Mau pulang.
Tapi jalannya jangan sampai ke bawah ya. Jangan ke
Kalau
lantai
mau
satu
pulang
cuma di
gimana?
depan atau di ruangan. Karena kita hanya waktunya 5 menit. Dan nanti setelah itu masuk lagi.
Nah, nah, nek apik ngoten Pak, nek apik.
Malah bos itu kayak
Iya. Malah seneng kok.
baru pakai dikit. Oh iya, mas ini mas.
Bro.
Jelas 45. Pas. Jadi yang iya. Kan mas gitu. Kan begitu gitu. Iya. Harus gitu.
Apa nggak ada pertanyaan? Apa ini? Nggak ada. Betul jauh di Mawar. Iya.
Kita pertanyaan ini malah ada tanya. Orang
Lah,
di yang
ya mungkin pun mudeng Pak, orang mudeng ini.
ini. Karena kemarin ternyata tidak ada pertanyaan, jadi sekarang harus ada. Nanti ada kita beri kesempatan ya dua mahasiswa dan dua mahasiswi. Nanti yang tanya dapat if you want to get give question for the presenter, you can get freelance with me, freelance with me. Selamat siang, tapi mungkin tidak hari ini, besok lusa atau nanti kita ada makan siang gratis dengan saya di sekitar kampus saja ya. Saya sebelum diundi siapa yang mau tanya nanti ya, nanti setelah selesai ya. Tanya ya sekarang tapi disiapkan dari sekarang. Saya cari dulu dari sekarang biar nanti kita tidak menunggu lagi yang mau tanya. Dari nah ini ada 4 ya, ada 4. Nanti perwakilan satu-satu. Oke, dari sini yang mau tanya for question. Mau? Tanya dalam bahasa Inggris bisa Google Translate dulu. Kalau enggak ada, kita undi. Belum ada?
Belum,
Ada?
belum.
Sebelah sini, Mbak-mbak. Mas, nanti yang mau tanya? Mau?
Enggak.
Oke, sudah dapat nih, Mas Adam. Ada yang lain boleh? Satu.
Bawahnya kan ngotot yang
Di sini yang mau tanya? Oke, oke kita ada dapat 2 laki-laki. Yang perempuan belum? Mas siapa? Mas Danang. Mas Danang dan Mas Adam. Oke, sekarang ya. Question for the no, the last section.
Okay, thank you very much. We'll take your questions after this presentation. I hope you have questions for me as well as for Dr. Farah. Let me start my part. Be attentive, please. Are you okay? What is SDB? Anybody? What is SDB? Special data. Well done. Excellent. So, thank you. Visualization, I take it as for vision. It's a vision. Spatial data added with where the vision is going now in this high-tech road. That's what I call notable development in STV. What Dr. Farah has told you, she has covered all the basics of spatial data visualization. But I tell you right now, what is spatial data visualization going to be in few years' time, and what is now we are seeing the technology. First thing, spatial data visualization has gone from simple visualization to augmented reality and virtual reality. So before I talk about how spatial data visualization is integrated with augmented reality and virtual reality, we need to know what is augmented reality and what is virtual reality. So one thing I will do with you, I'll introduce you these two terms and I make sure that you understand what is augmented reality and what is virtual reality. That is needed. If you are a geography student, if you are doing spatial data visualization, if you are a cartographer, if you want to do anything in future or right now, you should know this what is augmented reality and virtual reality. How many of you have heard these terms? Augmented reality. Have you heard this term? Virtual reality. Have you heard this term? It's in now, and I will explain. Next thing, I will explain machine learning and artificial intelligence that is being integrated with spatial data visualization now. So it's not only simple maths, no more maths, more than that. It's going to be an intelligent math. Okay, and we take doing a lot of artificial intelligence and machine learning integrating with spatial database. Now, a lot is going on cloud-based spatial data visualization, and you know what is cloud? What is cloud? Cloud-based computing. It's online storage use of spatial database. So cloud-based SDV is in, and interactive dashboard is new thing. So SDV has been integrated with this and mobile SDV. Let me start with first. Let's look at this picture carefully. You may have some of you have inferred that. What is going on here? Somebody is sitting with a mount head on the top. Of course, it's sitting somewhere and visualizing a bird that is about to fly. A bird is sitting around this cloud outside. World, these are not real. Not real. So when head is mounted here, through glasses, what I see, the bird is not real bird. The cloud is not real cloud. The door is not real cloud. But what visualize is visualizing. What we have done here, we have enhanced the vision. Something is not existing. But with the mounted head, you can visualize. Right? There are special glasses actually put there, and you can interact with them. So you can do this, you will fly. There's no God, there's nothing. It's just like dreaming. You are dreaming at time, and you see so many things. So that's what virtual reality is. It does not exist through computing vision through databases. We generate something that's virtual. Hope it makes you clear the term virtual. So it's not existing, but you can see. You can still do fish and bird is flying. No word, nothing, but you have a feeling. You are interacting with virtual reality. But what is then augmented reality? So immersive environments are produced. These are called immersive environments. They don't exist really. You have played a computer game car racing. Have you played that? Girls, you may not. Boys, must have played that car racing. There's no car. There's no road. Something is in your hand, but making a car is going and you're with car is going racing. You're racing the car. That's all virtual environment. That's VR. And in spatial data visualization, now a lot of development is going on in VR. So we create immersive environment. So it's on top of Dr. Farha explained vector database, vector database, visualization. We are using the same technique, color, symbol, image, isoline, something. All that has been developed so far in spatial data visualization, but now it's more than that. We are taking that spatial data visualization into immersive, intensive FDV experience, and that's a virtual reality. So tomorrow's cartography, I said cartography is no more. It's a spatial data visualization, but tomorrow's spatial data visualization is more than that. It will be immersive environment. Maybe you are at home, you are attending a lecture, you are learning spatial data visualization, you are learning when there is no Prof. Nawaz, no Dr. Farha, no classroom, but you get a feeling that there is a classroom, there is an environment, there is a map, there is everything. That will be the virtual environment, okay? What if next time I teach you through this environment? Would it be okay? You can attend from home. During pandemic and NUS we did this, we created this universal environment. So it was spatial data visualization for another level with augmented and virtual reality. So we explore 3D environments. You see, maps are 2D. The real world is 3D. I'm a 3D object. I'm a 3-dimensional. Why I'm 3-dimensional? Why I'm 3-dimensional? And we all are 3-dimensional. Why? Hello? We have length, width, height, volume, and we exist. And I am a spatial object. I'm moving, so I'm mobile object. That's how the real world is. There are objects, there are spatial objects. So if we create those spatial objects in AR, VR, we can create reality. And that's what we are doing. Spatial data visualization heading toward 3D reality exploration and 3D environment. Now, the next level of visualization is AR and VR thing. So combining all principles of spatial data visualization, integrating with AR and VR. So let me explain a little bit what is AR, what is augmented reality. It's so confusing nowadays. Tell me one thing, am I real? Am I real? Sure. I'm real. Thank you. Then you are all real. You are reality. If tomorrow you see me here as a hologram with a mic talking to me when I'm in Singapore, will I be real? No. That will be my some of like imitation of me, but I won't be. Real reality, now we turn, there's so many realities in spatial data visualization that we have to define the real thing. In spatial data visualization, new spatial data visualization, I am not defined as a real. I'm not defined as a real. What is the term for me? You said you are real. In spatial data visualization, I'm not real. I am actually what I am double R. I'm real. So I'm real. What is this is called R. Now I give you example. Can you see the photograph? Girls, what's going on here? That's the hand. It's your hand. It's a girl's hand. It's my hand. It's real. But I said so many realities in spatial data visual science. This will be called real, not real. So that's real. And you have an app on your mobile. You pick your hand, now your hand is there. Is this real inside your mobile phone? No, it's your hand, but it's not real. What is this? This is representation of real reality. So your real hand there. Inside is not real, but still it a representation of real hand. So this is representation of real realities RRR. Bad thing we have to ask, we have to define the real now. So it's a, in spatial data we will say RRR and there is a ring. And in this app you have a 20 rings. So you click a ring number 1, you look, it looks beautiful. What ring? What is ring? It's not there, it's in the app. It's a virtual thing. So ring is a virtual reality, VR. Your hand is RRR. And your own hand is RR. Are you with me? What the spatial data visualization, new spatial data visualization, this looks miserable. So you said I'm real. No, I'm real. You have to say real because the things are developing too much. Then if you look me in the phone, then I am triple R, I am representation of the real reality. And the ring is virtual, that is VR. So what's going on here? So you have VR, ring, you can change one ring, other ring, another ring. So you will select out of 10 with your mobile phone, 10, 20, whatever you like. This is good, pay. Gone. But what you have done here, you have combined real reality with virtual reality. So it's a combination of real reality with virtual reality, and you did a shopping water ring. This all has been developed on top of basic XDV. Did a shopping, and you never knew what you did. It was spatial data visualization. You combine real reality with virtual reality, some combination of that helps do the shopping. So the same can happen for other applications, for land use mapping, for other things. This was one example shopping. Let me go there and define the two. What is RR and what is VR? So now you understand. Come on. Now you understand the term RR. RR. What is RR? Physically. So you are all RR. You are RR. RR. Who is Dr. Farha? RR. We are real. Okay, good. So, on the other hand side, what was the ring? Ring was not available on the phone, but it was an image of that. That was virtual VR. Okay, so now I define, you understand that those terms VR and RR, you don't need to define, you don't need to memorize. Now you really know what is RR and what is VR. VR is something that is generated by the system, that is created by the computing, based on computing, that is created by algorithms. So it's something which does not exist in the reality, but it's some object that we have created that is still a spatial object. It is VR, virtual spatial object. Do you remember this VR and AR? Third term in spatial data visualization, that is AR. So we have already RR and VR. Now AR, what is AR? AR is augmented reality. You have a real world environment and you have a computer generated environment. Here is real world environment. It's your voice, this time is yours. Sorry, girls. This time voice yours. It's your real hand. And what is this? your hand inside app, what you will call it? RR is your real hand. This is RR. When it is inside this, triple R, representation of real reality, RRR. And now you tell me, what is this wristwatch? What is this wristwatch? It doesn't exist. It's created. Wristwatch has been created by the app. What is this wristwatch? VR. It does not exist. Still, you don't have. It is somewhere a segment of that. So it does not exist. So now we have combination of RRR and VR, and based on that we are getting AR. AR is when you have combined the representation of real world with virtual environment. It is called augmented reality, AR. So third term, one is RR, triple R is representation of it. So combination of triple R and VR is augmented reality, and we are creating lot of applications. You are using it. You're using it. You have a mobile phone. You have an app. You go. You say click. It tells you Arab Street, and then names of the shops. So you pick the street, actual street in your mobile phone. If you have app downloaded for the Singapore, to pick the actual street, and it will be augmented with all virtual shops, coffee shop, sweet shop, and shopping area, all other information. So that's what you're using right now. Are you doing this? Have you done this? So you are already using advanced spatial data visualization. You're using the combination of AR and VR day and night, and you don't know. So you're doing actually using the product augmented reality. So augmented reality. We pick the road, then you have all information about the road combined, and that's how it works. So augmented reality is the combination of VR and VR. RR, and on this side, if there's more VR, it's virtual reality. If more RR, it's real world. The good thing we are doing in spatial data visualization. So it's more than vision. We have enhanced. We are combining AR, VR together, and this is not enough. So far you have heard real RR, triple R, VR, and AR. Is it complicated for you, or I made it simple? Simple. So you know what is VR, not real, computer generated thing. RR, real thing. RR, triple R, representation of that. That's what we're doing in spatial data visualization now. We're combining, we are creating, taking advantage of them, doing a lot of shopping, working, going, finding direction, this and that, so many things. That's what you're doing every day. And you don't know that you are using advanced spatial data application. Guys, you are using advanced spatial data application. Behind all principles, symbolization, all these basics are the same. They are not changed. What we have done, we have taken to the other level with VR, AR, and RR. And realities are not simple. They are not simple. There are few more R's. So we have already, how many R's we have counted? RR1, triple R2, VR3, and AR4. So we have 4 types of realities right now. What the spatial data visualization scientists has made us to think. Sometimes it looks too bad, so many realities. So we have already discussed 4 realities. Okay, would you like to know more realities? You are familiar, I'm sure you have used, and you never know that it's SD. It's a spatial data visualization. There we go. There are a few more realities. Here you see something. Augmented reality sandbox. Smart idea. I have created augmented reality sandbox to teach the students. Actually, I don't teach, we just enjoy it. We make fun. We laugh, we stand, we do something with the sand, we learn, and we do something. This is what I made for my students in National University of Singapore. How we started. Nothing, simple. It was so simple. So we have a box and put the sand in box. We have a system. We bought a short throw projector that we have projector like this we have here, all projector and one 3D camera. That's it. So one camera, one projector and sand. Nothing else. And using these three things, we created a sandbox. Here you see the sandbox. In the system, we are running software creating virtual reality things, virtual simulation for flood, virtual simulation for rainfall, virtual simulation for everything, so many things those students are creating. And then we are running flood modeling. I teach flood modeling using this sandbox. We make mountains, we make hills, we make rivers, and we sometimes make Singapore here, and then we make a lot of rainfall, and then we destroy the whole Singapore road and gone away. That's what we do and what we play. That's the sandbox. So spatial understanding, 3D understanding of the nature, we are using with this augmented reality sandbox. And now you are familiar with augmented reality. There's a new type of spatial data visualization, and I'm using this augmented reality sandbox to teach spatial understanding, to teach students that how flows accumulate, how different landscape parts form, and how the things are going. We don't have to bother to listen to my lectures. They come, I say do something, do hear the flooding, they do it, and they learn. So they don't have to listen to my long lectures now. And I won't go to lectures. Okay, I'm here because I don't have sandbox. Next time I come, I may bring the sandbox, but it's heavy. It's not easy to transport. I tried this time, but it costs a lot. But what fun. Augmented reality sandbox is a spatial data visualization. You come, you do, and you learn. You know, if there's that much rainfall, there will be so much erosion. There will be so much flooding. So without bothering, you are learning. That's a great thing, spatial. And it's not only teaching and learning, spatial data visualization, new spatial data visualization is doing a lot in shopping, in costing, in budgeting, in so many things, in landscape mapping, so many applications of that. This guy is the new spatial data visualization. Okay. Remember, to do this, you need some software tools, some apps. And Layer SDK and Bufloria, they are excellent one and they are free. There's a freeware. If you tomorrow want to do this, it's not that Dr. Nawaz can do this. Unload, they are freeware. Make use of that and do the sandbox and all these things. These are all augmented reality sandbox. There are so many applications if you're interested for 2 weeks. All these things. And they are enjoyable things. If you are really geography student and you are interested in geography, rather than playing games and spending your time, most of the time on YouTube, I'm like you. I don't have much knowledge. I don't think I'm knowledgeable than you. I'm like you. I play this sort of thing and I created sandbox, augmented reality sandbox. And that's beneficial for my students. So I also want to play. Believe me, I am 59 years old. Inside me is 15. I play these things. I love to see the cartoons. I sit with kids and see the cartoons work because that's a visualization and you learn a lot. I still see the cartoons, small cartoons the babies say when they learn things. I watch that cartoon for hours sometimes. And that's the only thing I like, I love. Okay, soon I'll be grandpa, inshallah, I'll be grandpa, but I will enjoy the life with the kids. Okay, so that's the application if you want. Now I tell you there are few more realities, and I'm sure you will be interested. Can you count the realities I talk about you? By now, 4. Let's count. What was the first reality I discussed with you? Hello? Real reality, thank you. Clap for this group. That was first reality, thank you. What was the second reality I discussed with you? Triple R, thank you. Clap for this. Representation, and you know what is it? Oh, thank you. You know triple, what is it? What is the third reality I discussed with you? Third, VR, virtual reality, that does not exist but it's created through system. So it's a system created bird, car, all 3D environment. That's virtual reality. So here you see virtual reality. Here you see augmented reality. That was the fourth I discussed with you, augmented reality. What is augmented reality? Mix of the triple R and VR. Thank you so much. A clap for this group as well. Great. VR and triple R. So that's virtual reality, augmented reality. So you know augmented reality, VR, and there is another reality that is called MR. Oh my God. Reality number 5, MR. Guess what? Muhammad reality, me, Muhammad Nawaz. No, MR is for mixed reality. So that means RR, triple R, VR, we mix all and we have a fifth reality, mixed reality, that is called mixed reality. And we are advancing, there is a technology, we can develop that so we can bring in all the reality and we do whatever we want, we take advantage of that. And on top of number 5 is number 6 reality. And that reality is known as XR. Guess what is XR? It's called extended reality. So when you have mixed reality integrated with another reality, and now technology is too much, we have application, we have a lot of computing power, we can do that. So we can do the extended reality. So mix reality with any other reality, it will become extended reality. I give you one example of extended reality. Okay, here we go. Now you look at this picture carefully. No, not so carefully. Not so carefully and see what is going on here. Just see what is going on here. Oh, this will not work. This will not work until I touch it from the screen. All right. Here you see carefully. Just see what's going on. And you are very happy. You're very happy. Okay. But just think about reality. Okay? Don't see any other thing. Reality. Okay? What's going on here? See what's going on. Reality, you will tell that this girl is what type of reality? This girl. What type of reality is the girl? RRR. Yes. It's a representative of the, she is not real, but it's a representation of the real reality. It's a triple R. And what's the other dresses are going on? What are the dresses? VR. Dresses are the VR. And what she is doing here? She is changing a lot of dresses. She pick up, that's virtual reality. She is triple R now, and she decides which one fits. You should have wear scarf actually. I don't like, but there was no example with scarf doing all these things. Sorry for that. So in the mix, you see the reality, virtual realities, and this has some application. So at home, you can do the shopping. You have an app, you hundred of dresses, change 1, 2, 3, 4. I was teaching during pandemic on Zoom, and actually what I was doing, I was running most of the tutorial by recorded lectures. And for Q&A, I would appear all of a sudden, and students were asking questions during pandemic, 2020, 21, and 22, when we were working from home. They will ask, Prof, when you started the lecture, you were not wearing this shirt. I said, I have shirts on Zoom. You like me to change the shirt right now? I was just joking. They didn't realize that my lecture was recorded and I was only running because I was running in groups so much.
So recorded lecture has a different shirt. When I recorded the lecture, the shirt was different. Now I'm running Q&A live to give a feeling that they asked me when I answered them. I was using there was triple R and all this combination. I said I can change the shirt now. I have so many shirts on Zoom. He's changing the shirts there, but now you look at this. Now I take you to another level, and I need your kind attention. Have you got some energy? Now you see where the spatial data visualization is going. It's bringing its eyes of the car now. So cars had the lights before, front lights, headlights. The headlights you drive all type of cars. But now the car's headlights are more than that. The headlight is in Tesla car headlight is a strong sensor. It's still a light, but it's a sensor. So what does this mean? That new Tesla cars have eyes because our eyes sense vision, we visualize, and that's a new spatial data visualization. So Tesla's cars, rather than headlight, have sensors. At night, they provide to the light and they also sense what is in front. Sensor. Your cars, the cars have sensors for brake, going back, and a lot of sensors. But these are eyes of the cars now, headlight, no more headlight. And what's going on in Tesla's car? A software is running. And those softwares are based on machine learning and artificial intelligence. Machine learning and artificial intelligence, like we have a learning model in Chat GPT. Are you familiar with Chat GPT? Yeah. What is going on there? It answers your questions. They are learning models, so their knowledge models working there. Every time you ask something or you say something or give something, those models accumulate based on that. The behind is neural network working on. Just like your brain is memorizing so many things, it's going there, it's processing. So what's the base? Is AI and ML integration working there? Why not this? Why this not work in the car? Tesla, Elon Musk is doing all these things. So Tesla has now from cloud, we have all information, and inside car, AI and ML models are good, and AM, LI, and AI technology has been integrated with their STV. So basic are still the same. These sensors will see still the symbols, the colors, the lines, the isoplane, the contours, the height, all these things. Remember, still it's the basic is same. But what we have done, other than headlights, we have created the eyes. Not actual eyes, but they are sensors like eyes. So they will integrate it, and you don't need a driver. You need to feed coordinates, and based on AI and ML integration, car will drive you itself to the where you want to go, and will say, "Get out, please. I'm in faculty geography now. Get out." So it is message all. That's the new spatial data vigilance, guys. So what Tesla is doing, based on same basic principles of STV, is creating AI, ML integration, and these cars. So these cars can identify the patterns. And your pattern identification base is spatial data visualization. Symbols, colors, graduated colors, all Dr. Farha was talking, still working. So base doesn't go anywhere. The basic things are the same. So what we have integrated few technical algorithms, AI and ML models with this, and SVD is driving your car now, and provision inside, it doesn't do any accident. If all database are safe, they are testing. Good on you. You don't need drivers. And I tell you, the time is not far. The time is not far. There will be AI and ML integration is there, and your car are doing the spatial data visualization, doing all augmented virtual environment as well, and working for you. for a good spatial data visualization. Right? One more thing. Don't confuse SDV. What is SDV? Okay. Now I confuse you. There is another SDV. Like reality, there is another SDV. So in this cloud-based SDV, based on cloud-based, cloud is cloud computing, that is all global cloud computing actually, the big, the cloud computing. So based on that, now we are creating some cars, and these are called software-defined vehicles. So don't confuse software-defined vehicles with SDV. Spatial data visualization is a science, and this SDV is a car. So you have a Tesla already in market, and the new car coming to you tomorrow, in next few years, is not Tesla, SDV. But SDV won't be spatial data visualization, that will be a car. It's a brand of the car that's coming in the market, and it's the same. AI, ML integrated with spatial visualization techniques, and instead of headlights, we have eyes or sensors, and these cars will be around. These will be the cloud-based cars. So you hire a car, you online put an order, car is in front of your door. That's the model behind. Okay, you go out, sit in the car, it will take you to the university, and it will drop you there, and then gone to the station. It's all controlled through software. That is a new brand of car called SDV, but don't confuse it with spatial data visualization. Okay, so it's a software-defined vehicles. They are coming, and it's all based on cloud platforms. So Meta platform, cloud computing. Guys, if you still don't know spatial data visualization, do it right now. Go on top of it. Look at the realities. Look at the ML and look at the AI, and that will make your life easy in the future. You will be the useful person if you don't go that way. So the coming time is ML and AI time. Doesn't matter it's a spatial data visualization, it's a geography, it's a medical science, it's anything. If you don't go that way, you don't embrace e-learning and AI technology, you will be left behind. I'm 60, I'm 59 years old. I still got hold of the apps. I work on the apps. I do the exercises. I try to integrate ML and AI as much as I can. I know I have 10 or 12 years, maybe I don't know how much life I have, but when I can do, you should do it. You are young. Don't lag behind anything. So anything you do, take care of advanced SDV, ML, AI integration thing, and that will save your life. If you are in geography, you should know ArcGIS, Esri products. ArcGIS dashboards are also AI ML integrated. Here you can produce dashboards, and so easy. You have real-time dynamic. You create an application in your real-time data. You can just observe and calculate the traffic density around Solo. You can have a dashboard on your system that tells you if they have sensor, and there will be sensor. Solo will be not sensorless, there will be sensor. Create a dashboard. So online interactive dashboard, and Esri is doing a lot. If you are learning ArcGIS in geography, ask your professor, touch this dashboard thing. Never you must learn what is dashboard in ArcGIS, and that will make your life easy. Another dimension of SDV is mobile SDV. I don't need to tell you. You are using every day. When you look for the directions at unknown place, you're using mobile SDV. Right? It's a mobile SDV. And in mobile SDV, you can identify there will be something virtual, there will be some, there will be RR, there will be RR, there will be VR, there will be VR. And tomorrow, these apps on your mobile phone may be XR and MR in it. This is all spatial data visualization, guys. You're looking for directions, maps, all these things is spatial data STV. It's advanced STV integrated with ML, AI, and AR, and that's what we use every day. That's mobile STV. And if you want to really develop something, their batch, your ArcGIS Online and Carto, these are three softwares. ArcGIS is proprietary, it costs you. Others are free. But I would advise you, if you have some time to enjoy, if you have some spare time, don't waste it. AI, ML, virtual realities, augmented realities, all these apps will teach you a lot, and they are nothing less than any computer games. So don't waste the time on bloody busted YouTube videos. These provide you enjoyment. I enjoy this app. I learned. That's why I had an augmented reality sandbox made. You can do a lot. You are young. You are brilliant. You got talent. Direct yourself, learn modern SDVI and do something. That's what I will expect you. Thank you very much for your attention. Any question? I say 15 minutes for your question, guys. If you want to ask question, I will start asking question. Any questions so far for me or Dr. Farha? Okay. Can you tell me? I have requested something. Can you tell me what's my special request to you today? What I have requested? Direct yourself. You will enjoy. Do something positive. I give you a message. You will lag behind. You will go behind if you don't touch augmented realities or realities. If you don't touch machine learning language or artificial intelligence, try to do something in this area that will take you up front. Right? If you don't touch this, you will lag behind. As a student, as a mom, as a dad, as a person, you will lag behind. I can talk more than my kids. Well, my kids are no more kids, 28 and 30. Still they are for me kids. Because I learn all this thing, I enjoy all this thing, okay? Other thing I requested, rather than wasting on all social media thing, direct yourself, please. Embrace yourself the new technologies. Get on top of it. You should have a knowledge about electric vehicles. I know, I'm an old man, I know Tesla will be replaced by ST. And I need to tell you that ST is the brand of car, not special data visualization. But why its name is ST? Have you thought about this? Because this is visioning like basic principle we have in spatial data visualization. But this is software. It's all software working in the car, and that's the new brand ST. Thank you so much. Any question for me or Dr. Farah? Or you can ask them in
Give applause first for the and
Sorry, sorry. Not for me, not for me, not for me. I can see from that corner to that corner, everybody was looking eye to eye. Thank you so much for being such a nice audience. A big hand for you from me. I can tell you, nobody was sleeping. A big hand for all of you.
Yes, sir.
okay, thank you, Dr. Hamid. Thank you. Next question is Nathan B. For the process Mas Sadam, right? Mas Sadam.
Perkenalkan, saya Sadam. Di sini the question about Farha. Can analyze using NDVI also be used phenomena such as COVID-19? You mentioned earlier on the net as an overlay. Is the analysis effective?
So you are asking about NDVI?
Yes, NDVI.
PI for what?
For phenomena such as COVID-19, which you mentioned earlier on the net.
So he has written here, it will be easy for me to read his question. So his question is, can analysis using NDVI, this is not B, so this is VI. And yes, that's yeah, NDVI, that we use in remote sensing. Also we use these phenomena such as COVID, you mentioned earlier on the map as an overlay. Is the analysis effective? Okay. So first of all, we need to understand what is so what is what is NDVI? That's natural variation index, NDVI, and that we use for when we have to analyze the phenomena that where vegetation is involved. Because then, if you want to, and you are saying that can we use that NDVI for to analyze the COVID related application? That's what I'm saying. So first of all, you need to know you want to make relationship of the vegetation with the COVID. Does it make sense? Or to study that how the vegetation has that the way moves with the COVID system. Then you can make use, but normally you use NVDI mostly with the vegetation mapping, making different classification of vegetation. So maybe using and the remote sensing, we make use of that's with the red and the near infrared band, or to classify the different vegetation classes. So that will be more related to the vegetation side. And with the COVID related phenomena, then I think it should be more like, with the health things. For example, how was the health of the people who got COVID? Or maybe what are the after effects of on getting the COVID on their health? Or maybe you want to study whether women get COVID or more male or men get COVID, gender related things. Also, age, whether young people got more COVID or maybe older people, they were prone to catch or get infected by the COVID. I mean, the first thing is you need to clarify what you want to investigate, what you want to search, and then come towards your method, your methodology, what you will be using as a source, as a tool, as your strategy to come up with the different answers of your questions. Okay, that's just my question to you all. When there was COVID, so in which part you are more interested to find out who are getting that food? That was the first. So maybe like at what part of the world where it is spreading more rapidly. What is the ratio? Maybe boys are getting more, or the girls are getting, more cases who got that. Then the people who died with COVID. if you just look at the statistics, how many people, died out of that? But who were the people, or maybe the number of persons who died with the COVID who have age more than 60 years of old? Or the people who recovered from COVID, but in which age group they lie, whether they were less than 50 years old or maybe they were just the young people, because we assume that the young people have more immunity to fight with the diseases. They have that the natural immunity. They are in a age that where they can fight back the diseases and based on the energy, based upon their immunity level. While the older people, they don't have that. So, I mean, related to that kind of studies, first of all, you need to rectify what you want to get that. Because with NDVI, that's like a remote sensing thing that we use for the natural, the vegetation, natural vegetation index. And but that's only when you are working with if you want to identify, okay, there is an area, for example, in Solo and in the vicinity, you want to identify what is the health of crop, in which areas you got really, really good crop, and it can be anything. I'm not
Hello,
sure
Pripon,
what the crop here.
Halo, halo, halo. Waalaikumsalam. Pripon?
High production there. So where
Belum, ini mau selesai. Baru pertanyaan terakhir.
Ready seeds here. Where you
Nggak
are
tahu ibu
growing
dia.
rice. So in which area are you or growing rice here, or in what part
Ini udah mau selesai sih, Bu. Udah mau selesai.
whether it's not suitable
Pripon?
for growing for a particular type of crop, or maybe that for growing a pine trees here, whatever. But we need to identify what is the relevant. First of all, it's more like health related things. It is more like effect on people, how the families have been affected. Then that's a study. That means you would like to identify what to study. So related to your study,
Gak apa-apa.
Udah, masih 3 lagi.
Siap.
something you then it is because in the real infrared, and when you take the overhead and with the infrared band and the infrared band, then you can see the
Langsung mereka mawar.
Is there any other question?
Betul, langsung mereka mawar.
NDVI is on landscape planning, all the big thing. I think it's not good. But if you are cover-related research doing, I can give you a research question.
Tereng belum.
Maybe a bad example, but it can produce a good result. My family is 4.
Buatan saya langsung mereka mawar.
I know here are the big families, 6 to 8 children and all. We are 4. 2 of my son, 1 wife, and me. So all males at my home had a COVID. 2 males have COVID twice.
Oh,
All females does not have COVID. It's a research question. Word over how many got the COVID? I think 25%. 75% male got the COVID. That's a research question. Do something like that rather than anything. There is an interesting question now. Okay? You must be interesting. Farha didn't got COVID. He take care of 2, 3 of us. What does this mean? We are husband and wife, okay? All right? Do you know that? Okay. She haven't got the COVID. And I think whole community of female, 25% female, maximum got the COVID, 75% male. Males, your immunity is down. There's a research question for you based on bad example of my household. Do something like that. NTVIS applications are remote sensing, landscape, big pictures, big things, sensory, all these things. But COVID is something else. It's a pandemic thing, it's a disease and all this. I want to add the example. Okay.
Thank you. We have 3 questions again. Okay.
Please, you can speak in
Let me introduce myself. My name is Jana from the Geografi UMS. I would like to ask about the map material that has been present by Dr. Farha. In your opinion, are visualization techniques such as symbol, colors, and gradients used to clarify spatial patterns on thematic map? What happens if the colors or symbol used are not appropriate?
Okay, so how are visualization techniques such as symbols, colors, and gradients used to clarify spatial patterns on thematic maps? Uh, and what happens if the colors or symbols used are not appropriate? Okay, so
Thank you.
that's a good question. Okay,
That's not a good question. You can see that.
yes, that's I know that the spatial data visualization techniques that where we can make use of selection of standard colors. When I said, okay, you can make use of topographic maps, and with topographic maps, you can see the contours there, you can see mountains, we can see the standard colors for water bodies, and then being for the plain areas, for the mountains, it's a gradual, that the color ground, and how show that it's the bright color, and so these are used as standard selection of colors. So what happens if we are not making use of standard selection of colors? We are not making use of appropriate symbols. So it means that you are not showing your data in a way that is easy to understand. For example, if on a map I am showing rivers in red color, and if there is no legend for that, can you understand what those red color mean? The red line means, because if there are, that the blue colors lines on a map, you can easily understand, so there are numbers. But if there are, the different colors, what if I use, let's say, orange color to show pine trees, pine forest here, or if I use, let's say, magenta color to show that the paddy field here. Will it make any sense to you? What then the magenta color is representing? If there is no legend, so selection of colors and symbols is really, really important when you are showing your data using spatial data visualization. If you have not selected the right symbol, the right color, so it means that your visualization will not be effective. It will not convey you the actual meaning of your data, of your associated data, which you want to convey to your audience. Because when, as a geographer, when you produce a map, what does that mean? That you are sharing that knowledge, your information with your other geographic community. They might be your peers, your class fellows, your teachers, maybe other persons are using that data. And if you are not using the right thing, that you are not showing your data in a meaningful way, you are not conveying the actual information, the actual thing which you want to share with the rest of your geography community. So it means that whatever the hard work you have done to produce that map, right from your data collection, processing, analysis, making those layers in your GIS software and your end product, your final product, your final map. That is not with the right information. And if you want to make some decision making for some problem, for example, if you remember that I gave you an example of studying, that you want to make some solution how you are going to control flooding. And if you are not producing your map, you maybe after the analysis, maybe you are showing the rainfall information in a wrong way. So the other person they are not getting what does the map show? You are showing the population density of Sulu or of Sulukata using not the selection of the complex map, but showing in a different way. This is not showing the information in an effective way. And other persons who are also involved in the decision making, they may lead to make wrong decisions. And being geographer, being analyst, using those techniques, what you are helping? You are helping your policy makers, your authorities, your government to make use of that information, your research information, and make the right decision. So that is beneficial for your people, for the whole nation, for your community, for your area. So if it is you are producing the information in the wrong way, that will be the wrong decision, and of course you have back the whole on all the persons involved with that policy. I hope I answered your question.
Okay, Mas. Okay. Thank you, Dr. Ha, and the first.
One more question. More?
Maybe two question again. From okay, the question from Emma.
Hello, my name is Emma from Science Information Geography. I have a question for Mr. Nawaz. I want to ask about the material explained previously about AI. So my question is, does AI have a limit?
Thank you so much. She's asking that AI have a limit. Excellent question. A big hand for this question. Thank you so much. Whatever you think of in the knowledge word has limit. Everything is limited in this whole universe except one thing that is unlimited. You know better than me. Allah. Everything is limited. The rest, everything is limited. AI has limit. And AI won't be able to cross that limit. So it's a limited knowledge. In astronomy, we right now with the Voyager 2 and 3 going beyond solar system and all billion and trillion galaxies we have seen, which know there is no limit. That's another thing. Otherwise, our knowledge is limited. Our knowledge is limited. Knowledge, all type of knowledge, AI is a type of knowledge only. That's it. I hope I answered your question. Thank you so much for asking. Okay, it's limited.
Thank you, Dr. Nawaz. Clear? Okay, the question from that. Okay.
Okay. So now let me introduce myself. My name is Rija Aulia Putri. I'm first year student from the Faculty of Geography. And I would like to thank for Mr. Man and Mr. Farha for their very interesting presentation. As a new student, I would like to ask question for Mr. Farha.
And don't call me Mrs. Okay?
It's about maths, especially the topic types of maths. Ms. Farha, in thematic maths such as population density math or unit maths, what are the main differences in how the data is presented compared to topography maths or log maths? Or is it the same or focus or specific maths? Thank you.
So, okay, so question is in thematic maps such as population density maps or climate maps. What are the main differences in how the data is presented compared to topographic maps or road maps, or is it the same or focus on?
Okay, thank you.
Very good question.
So the question is regarding when we represent data in thematic maps and as well as in topographic maps. Remember, two things. With the topographic map, it provides the information related to topography about the Earth's surface. What is the landscape? Where we have, the high elevation point where we have the main areas in relation to the mean sea level and as well as the water bodies. So with the topographic map, there are some standard features which you can show on the topographic map and more or less all of the topographical map you will see same information like standard information. So it is more related to the spatial part, spatial component. Related to the thematic maps. With the thematic maps, they are based upon what you are going to identify or what you are going to study. They might be some spatial component, maybe in some area you want to study slope, maybe aspect of the terrain or of the topography. So yes, that can also be studies as a human, but you can also want to see some other things. For example, maybe you want to see the population density. That might be one. Maybe you can also see what is the health of people in a particular area, in a district, and how it is relating with those special components. For example, okay, if people's health is really good, they don't have many diseases like maybe the population who have a more than 50, they don't have high blood pressure, they are not diabetic, they don't have any heart problem. So maybe that so you want to identify the health of the people, but you also want to, let's say you want to relate it with that, how it is related with the spatial component in terms of the landscape, in terms of the availability of clean water there, availability, or maybe in terms of the weather or the climate, then maybe you can imagine just combining topographic map and the thematic map and the other information related to it, and then you are combining all those layers together. And then you are making connection to identify that, the problem, the health problems. And then you are identifying, okay, the people's health is really good in that area, but maybe there the climate is really good. there is not much humidity. There is not much, high temperature. The area is really well vegetated. They really have good living condition there. Maybe you can also want to add some other key maps, availability of the facilities of health facilities, availability maybe of getting the clean drinking water there. So this also contribute towards the people's health as well. So these they all have the different themes for you related to identify the health of the people. But so it means that you want to analyze that in relation to the spatial component which the topographic map will provide you, but you can also study or to identify the socio-economic things, socio-economic related, themes there. So yes, they both of the maps they will provide you different information, but when using the right data visualization technique, performing the right analysis, when you are combining everything together, you will be getting the right decision, the right answer. Yeah.
Okay, thank you, Dr. Farha. Maybe enough. That's over. Okay, thank you,